So sorry for that interruption. My Zoom account is only for 40 minutes, so I'll try and finish up whatever it is that I had here, which I wanted to talk about, and which was about building, the knowledge based. And remember, I said that there are two approaches we can use to build a knowledge-based agent. We can use declarative or procedural. But in most cases, most AI systems that we have both of them, declarative and both procedural approach used. Declarative is whereby you build from scratch. Okay, here you build the agent from scratch, telling the agent what it's supposed to do. While in procedural, you encode desired behavior as a program code. So what does encoding mean? It means that you have knowledge from an expert somewhere. You have either these 5 types of knowledge. In most cases, it's heuristic knowledge. You encode that heuristic knowledge into the knowledge base and then into program code so that this system can be able to behave the way you want it to behave. So declarative is whereby you build an empty knowledge base, and this empty knowledge-based agent is supposed to perceive from that environment what that knowledge will be and how it will behave. And procedural is whereby you encode knowledge, you encode desired knowledge as a program code, basically heuristic. And that's why they usually say you do both of them, whereby you encode this knowledge as procedural and then you leave it as declarative for essence of self-learning, because we want our agent to be able to learn on its own. That's why there's that aspect of declarative approach. Declarative approach basically leads to self-learning of a knowledge-based agent. So we have talked about the knowledge, types of knowledge that we have. Now, knowledge representation. What is knowledge representation? So knowledge representation basically is how do we represent this knowledge? Okay. So how the reasoning that we do, how can we be able to represent it? So knowledge representation is a key aspect of a knowledge-based agent. So we want to enable this knowledge-based agent to think like a human being, reason like a human being, and interpret knowledge like a human being. So we have those aspects of knowledge representation and reasoning, and representation of information, and representation of knowledge in AI. So that's what knowledge representation is. We have this knowledge that we are having. So how are we going to represent it in AI? That is what is knowledge representation. So the following are the kinds of knowledge which needs to be presented in an AI system. We need to represent objects. In programming, objects are facts in our world domain, e.g. guitars contain strings, trumpets are brass instruments. Objects, and even from object-oriented programming, we have a class animal. Class animal, we can have vegetarian, we can have herbivores, we can have carnivores, we can have omnivores. Under omnivores, we have human beings, we have apes, we have chimpanzees. So that's what we call an object. And then you have events. We have to represent knowledge in forms of events. We have to represent knowledge in form of performance. We have to represent knowledge in terms of meta-knowledge. We have to represent knowledge in terms of facts. And you have to represent knowledge as a knowledge base. Okay, so knowledge base is basically the group of sentences. So group of sentences which are what we call knowledge language. Remember, they are not the English-like statements that we are used to. No, they are not. They are knowledge language like of statements. So that's what we have with the knowledge-based system that we're having. So what is the relationship? Before I sign off, I wanted to finish off with what is the relationship between knowledge and intelligence. So what is the relationship between knowledge and intelligence? Okay. So here we have sensing, you have the decision maker, and then you have the action. So knowledge is really important in AI because through this knowledge, you are able to perform a certain action based on the knowledge that we have. For example, I'll give you a good example, the way you were when you are young. When you are growing from a baby, the baby steps, when you started walking and then you started running. It's like that way. It's sensing. The way a baby behaves, the way a baby will behave is it will sense and then it will decide. It will decide, and based on the knowledge it has, it will do an action. Because once you start walking, you can never stop walking because you have already sensed. You've already decided by there I can be able to walk. Why don't I just be walking? Like, for example, now you don't expect a baby who has known how to walk to suddenly stop walking and start crawling or lying on its back. No, that is sensing. So the thing that is the link between knowledge and AI and intelligence is that we need knowledge to inform our intelligence. So it's a kind of a back and forth. Knowledge feeds intelligence and intelligence feeds knowledge. Okay, that's one thing you have to understand. Knowledge feeds intelligence and intelligence feeds knowledge. One cannot work without the other. We need both. We cannot say we are intelligent if we do not have knowledge. And we cannot say we have knowledge if we don't have intelligence. It works both ways. So you need knowledge to have intelligence, and you need intelligence to have knowledge. As remember, we say that it is self-learning. It is an aspect of self-learning. Anything that is an aspect of self-learning, it should be able to evolve on its own over time. So that's what we have with that. So we have the AI cycle, which I believe you'll be able to look at it. Intelligent behavior, we have perception, we have learning, we have knowledge, presentation, and reasoning, we have planning and execution and education. It's actually execution, not education. This one is execution. Okay. So the next class we shall look at approaches to knowledge representation. I believe that will be the next class which we shall look at, because my time is nearly up also here. So I have another meeting which I have to go to. So that's what we have with the AI knowledge. You have perception. Perception is basically where you perceive. You perceive through learning and through knowledge representation. And then with knowledge representation, you have to have reasoning. And through reasoning, you have planning and education. And execution, not education. It's execution, planning and execution. So that's the cycle. And they're all ever encompassing and dependent on one another. So that is the AI cycle which I wanted to know, and the relationship between knowledge and intelligence. And we have said that knowledge depends on intelligence, the same way intelligence depends on knowledge. That's one thing. They are both symbiotic. One cannot survive without the other. The other thing which I wanted to talk about was something which I find to be really important, and that is the anaconda. I believe you guys have been able to, I want you to download this IDE, Anaconda. Just Google Anaconda, and then it will give you the Anaconda almost. It's a popular data science platform, whereby if you want to do any data science project, you use this. Then you come to products, then you come to individual edition. Then after you've come to individual edition, you come and download. After it has downloaded, let me stop sharing. After it's downloaded and you install it, you just come and look for Anaconda, and then you come and look for Anaconda Navigator. Anaconda Navigator, and then it will open up the Navigator. This is whereby we shall be doing most of our AI projects and everything. Even for fuzzy logic, we shall be using the Anaconda. So once you install this application, it's really important that you keep on using this application. It is really important, and you can even use it for your other projects and everything. It has a lot of IDEs which you can use in there. So it's basically a conglomerate of various IDEs. If I call them conglomerate, what Jesus, Kisungu. A combination of several IDEs which you can use to perform your work, because it has Python, it has Visual Studio, it has R. You can virtually install so many other applications there, but it's purely based there for what we call it's purely there for data science. So the first thing I want us to look at is install Anaconda. Then after you've installed Anaconda, you can access GitHub. I have talked about GitHub so many times. I believe I've even explained it to you guys. The thing which I wanted to talk about is another site which I call Kaggle.io. kaggle.com. I want you to go to this site, kaggle.com, and yeah, kaggle.com. I believe I can be able to sign in with Google. So you can just sign up with your Google account. If you have a Google account, it's way easier to sign up with your Google account so that you have one-stop shop signing in. So signing with your Google account. And it's quite easy to use this Kaggle. So this Kaggle is basically, if you're interested in data science, and you want to do a lot of data science, this is the best platform with which you can come and look at, because here you have a lot of things which you can do. There's even competition. There are even competitions which you can come and decide to join and see how they usually do their work. And here is where you go and gain a lot of information. You see the amount of money they have. Like for this one, this is the pulmonary fibrosis progression. And this one is basically a competition whereby they give you data and you're supposed to create a machine learning or an AI program which is supposed to predict if a person has pulmonary fibrosis progression. We have the Google landmark retrieval. We have the global weight detection, as you can see. Can you identify weightheads using image analysis? You have hash code archive, you have open objects. So it's basically on the Titanic machine learning. This is usually the best. Now you see this one. This one is about knowledge. So here they talk about the categories. So if you look at categories, you have research, recruitment. We never looked at research. Yeah, Conver, yeah, that's research. Global weight detection. Can you help identify weightheads using image analysis? I can check that. This is about deep learning, just deep learning. So here we can look at, you can come and search knowledge-based agents. So I believe there'll be something about knowledge-based agent, which I believe use agents, features to remove agents. So there are so many things. But my essence was not that. My essence was, with this, you have data. They have a repository of data. One thing I like about this site is the data they have. They have public, things we call public data sets. And these data sets are the ones which we shall be using when we want to write our AI learning codes and everything, because this data is what we shall be doing. Now, here is how Anaconda looks like. This is the Anaconda navigator, as I said. You have all these things. You have R. I believe when you install this Anaconda, I believe the ones which we shall be launched shall be the Python. I don't know if Orange shall already be launched. I mean, shall already have been installed, because I know Visual Studio Code is not installed. Mine I installed it. So depending on what you need to use, you can install. But I believe for most of the work we shall do, we shall look at Notebook and we shall look at Orange. Now, I don't know which one we shall use, but I believe because we're also going to do fuzzy logic. And fuzzy logic, we shall have to look at fuzzy logic. How do we write fuzzy logic programs, and also artificial neural networks? I believe for now we can be able to use Orange, because we shall also be looking at fuzzy logic. So install Orange. One thing I love about Orange, you do not need to program. The only thing you need to have is data, and then you just apply the algorithms to that data. They have already pre-programmed the algorithms. So their work is purely you just look at that data, you try and load it, and then you see how it behaves. And I believe, let's wait for it as it launches. We look at it as it launches and we see how it behaves. Because that's the good thing with Orange. Orange is purely, it is a very nice application. It's a very nice application for data analytics. I hope it launches. Yeah, it's launching. Let it launch. Okay, this is Orange 3.23. It's taking a bit of time to launch. Let me just close. I'll share these notes with you, do not worry. Save, let me just save the ones which are highlighted and everything. Yep. So as it launches, let's wait as it launches. It's supposed to launch. I don't know, it's not launching. Just refresh a bit. So as I was talking about Kaggle, Kaggle is very good because it has all these data sets, and it also has an online notebook. This online notebook, you can be able to come in and run your data sets as you wish. An online notebook, you can have a new notebook there whereby you come and run. It provides for you a platform whereby it comes an online IDE which you can come and use it. So you have a notebook here, you can have a script or a notebook, then you have advanced settings, and then you'll be able to go and look at it. So this is Orange the way it is. So we have documentation getting started. Let me just browse examples. So the example workflows, examples of things which I've done: interactive visualization, visualization and subset, file, data views, scatter plot, and then you have classification tree, you have principal component analysis, you have feature ranking. Okay, so all these are examples of cross validation. They also have misclassifications. So file and data interactive visualization. We have scatter plot. Let's look at classification tree. Let's look at that. So it has such kind of a scenario whereby you're able to come and just and just look at this information and be able to model it according to how you want to do it. So there's various things which you can do with this thing, and this is what I'm saying. The algorithms which they have feature statistics, they have neighbors, k nearest neighbors, they have discretization, they have outlier detectors, they have preprocessors, they have transpose, they have merge data, everything. So these are things which you can be able to come and look at in due time and be able to see how they usually perform. So here you can double click on this, then you can be able to see. This is the iris. These are iris. These are data set on plants. And these they are trying to classify plants according to whether they were setosa or veriscola. Okay. And we have the classification tree. That's the number of things which they have. Then these are the plots. As you can see, it can be able to plot for you quite comfortably how it's supposed to do. So we shall be using, I believe we shall try and look at using Orange, but you can also be using Jupyter depending on anything we have. But look at Kaggle and also look at Anaconda. So thank you for your time. Sorry for the issue we had with Zoom. It's only 40 minutes, so I usually say that I will be able to do this. I'll be doing this and then we stop. We look at the other way. So thank you very much and have a blessed day.